In this video, we're going to be solving a system of equations using elimination, examples 1 and 2. So they give us a box telling us the steps for solving a system of equations using elimination, and we'll see these step by step through the examples in this module. In 1, it says, solve using elimination method. L1 is 6x plus 5y is equal to 13, and L2 is 5x plus 3y is equal to 5. And they tell us the first thing we're going to do is multiply L1 by 3. So we have 3 times 6x plus 5y is equal to 13 times 3. And now we're going to distribute the 3 through the parentheses on the left side of the equation, and we get 18x plus 15y is equal to 13 times 3 is 39. And now they want us to multiply L2 by negative 5. So we have negative 5 times 5x plus 3y is equal to 5 times negative 5. And we get negative 25x minus 15y is equal to negative 25. In the next step, they want us to add together the equations that we just created by multiplying 3 times L1 and negative 5 times L2. So we have 18x minus 25x is negative 7x, and 15y minus 15y is 0. And then we have 39 minus 25, which is equal to 14. And now they want us to solve for x. And to solve for x, we're going to divide both sides by negative 7, and we find that x is equal to negative 2. And now we're going to substitute this value into either L1 or L2 and solve for y. So if we use L2, we have 5x plus 3y is equal to 5. And now we're going to plug negative 2 in for x, so we have 5 times negative 2 plus 3y is equal to 5. 5 times negative 2 is negative 10, and we have plus 3y is equal to 5. And now we're going to add 10 to both sides, so we get 3y is equal to 15. And now we're going to divide both sides by 3, and y is equal to 5. And now we're going to write the solution as an ordered pair, and the x-coordinate was negative 2, and the y-coordinate was 5. So our solution is negative 2, 5. And now we want to check the answer. So for L1, we had 6x plus 5y is equal to 13. And now I'm going to plug in negative 2 for x and 5 for y. So we have 6 times negative 2 plus 5 times 5 is equal to 13. 6 times negative 2 is negative 12, plus 5 times 5 is 25. And negative 12 plus 25 does equal 13. And now we're going to check it in L2 as well. So for L2, we have 5x plus 3y is equal to 5. And now I'm going to plug negative 2, 5 in. So 5 times negative 2 plus 3 times 5 is equal to 5. 5 times negative 2 is negative 10. And 3 times 5 is 15. And negative 10 plus 15 does equal 5. So the ordered pair negative 2, 5 is the solution to the system of equations. In 2, it says, solve using elimination method. L1 is 2x minus 11y is equal to 11, and L2 is negative 11 halves x plus 4 is equal to y. So the first thing they want us to do is multiply L2 by 2 to eliminate the denominator. So we have 2 times negative 11 halves x plus 4 is equal to 2 times y, or 2y. And now 2 times negative 11 halves is a negative 11x plus 8 is equal to 2y. And now they want us to write L2 in the form ax plus by is equal to c. So I'm going to add 11x to both sides. So I get 11x plus 2y is equal to 8. And now they want us to multiply L1 by 2. So we have 2 times 2x minus 11y is equal to 2 times 11. And now we're going to distribute the 2 through the parentheses, so we end up with 4x minus 22y is equal to 22. And now they want us to multiply L2 by 11, so we have 11 times 11x plus 2y is equal to 11 times 8. So when we multiply 11 through the parentheses, we get 121x plus 22y is equal to 88. And now they want us to add the equations. So we have 4x plus 121x is equal to 125x. And negative 22y plus 22y is 0. And 22 plus 88 is equal to 110. And now we're going to divide both sides by 125 to solve for x. So x is equal to 110 divided by 125, which can be reduced to 22 over 25. And now instead of substituting x into one of the equations, we could solve for y using elimination. And here you might choose to use this method because of the fractions. So to use this method, the first thing they want us to do is multiply L1 by negative 11. So L1 is now going to be negative 11 times 2x minus 11y is equal to 11 times negative 11. And when we distribute the negative 11 through the parentheses, we get negative 22x plus 121y is equal to negative 121. And now they want us to multiply L2 by 2. So we're going to have 2 times 11x plus 2y is equal to 2 times 8. And distribute the 2 through the parentheses, and we get 22x plus 4y is equal to 16. And now they want us to add the equations. Negative 22x and 22x is 0. 121y plus 4y gives us 125y. And this is equal to negative 121 plus 16 is negative 105. And now to solve for y, we're going to divide both sides by 125. So y is equal to negative 105 divided by 125, which can be reduced to negative 21 over 25. And now they want us to write the solution as an ordered pair. So we have 22 over 25 and negative 21 over 25. As the ordered pair that is a solution to our system of equations. So in problem 1, we did elimination once, and then we plugged in the value into one of our equations. In problem 2, we did elimination method twice. We eliminated y and solved for x, and then we eliminated x and solved for y. And now they want us to check our answer. So for L1, we have 2x minus 11y is equal to 11. So we have 2 times 22 over 25 minus 11 times negative 21 over 25 is equal to 11. 2 times 22 over 25 is 44 over 25. And then we have negative 11 times negative 21 over 25, which is plus 231 over 25 is equal to 11. And 275 over 25 does equal 11. For L2, we have 11x plus 2y is equal to 8. And now we're going to plug 22 over 25 and negative 21 over 25 in. So we have 11 times 22 over 25 plus 2 times negative 21 over 25 is equal to 8. 11 times 22 over 25 is 242 over 25. And we have 2 times negative 21 over 25 is negative 42 over 25 is equal to 8. And 242 over 25 minus 42 over 25 is 200 over 25. and 200 divided by 25 does equal 8. So we just verified the ordered pair 22 over 25 and negative 21 over 25 is a solution to our system of equations. And that's all for this video on solving a system of equations using elimination, examples 1 and 2.